Recording a couple of quick problems for everybody because these are the types of questions that we as a school struggle on the IO assessments. And with the IO assessments coming up this week and next week, we want to make sure that you are doing well on these and just kind of refreshed on as to how to do them. Okay, so the type of question you may see on the IO assessment has to do with perimeter. There's always some type of perimeter question, and it's not as simple as you'd see in grade school or middle school, but it takes a little bit more thinking. This one doesn't take a lot more thinking, but basically they're asking you for the same thing they'd ask you back when you were in middle school: is what is the perimeter of the rectangle below? Well, the perimeter, you should all know, is when we add up all of the sides of the rectangle. So if I'm adding up all of these sides, I'm going to take 4 plus, they didn't tell me this side over here. Well, I do see that they gave me the area of the rectangle. And area, I know, is length times width. So all I'm going to do is try to figure out what's the length of this side with that when I multiply times 4 makes 40. So most of you can figure that out. So try to stay one step ahead of me if you can. Okay, this side length would be 10 feet. And double check that. 10 times 4 would make 40, so that is correct. So now I know this side length, and if I know it's a rectangle, I can add up all of the sides. All right, if this side's 10, this side's 10, this side's 4, because this side's 4. Now add them all up. 10 plus 10 is 20, 4 and 4 is 8, so 28 is 28. So there's your perimeter, 28 feet. So there's just one type of question you may see in the sense of perimeter. Next one I want to talk about is the improper use of percents. It says, which of the following statements represents an improper use of percents? People fling percents around all the time and don't really know what they're saying. I heard a joke one time that says 75% of all statistics are made up on the spot, which basically is a statistic made up on the spot. Well, let's just look through these. Anytime I'm given choices that I need to read every single one of them, I start at the bottom. It's just a strategy that I use. I remember learning that as a ACT strategy from back when I was in high school, so I'm gonna use that here. Okay. The students satisfied 100% of the course requirements. Well, I guess that would be correct. 100% in this case would mean all. So we'd say the student satisfied all of the course requirements. Sure, that's a good use of percents. Part D says his farm makes up 1.5% of the entire county. 1.5%, that'd be okay. That's one small percentage, just less than 2% of the entire county. So that's logical. C says 85% of all bicycle accidents happen within 3 miles of the home. And yeah, that would be okay as well. It's just like saying I got an 85% on my test. B says profits from the concession stand last year decreased 125% this year. That sounds kind of weird. 100% would be all. And it says profits from the concession stand decreased 125% this year. So that means compared with last year, the profits went down over 125%. So that means over everything, because 100% would be all of it. So you can't tell me that the profits went down more than they had last year, like more profits. So that makes no sense, because you can't reduce the amount of profits over the amount of money that you have. So the most that it could be would be a 100%. It's just like you guys would say, I got a negative 25% on my test. That's not logical. So B is definitely not logical. You're probably asking, you're saying, well, that's over 100%. This one's over 100%. How come that one's okay? Well, the reason why this one's okay, it says attendance at a volleyball game increased 120%. What that means is that increased 100% would be all from last year. So say last year there was 5,000 people at all the volleyball games. Well, that means this year it'd be over 10,000, because 100% would mean doubling, 100% increase. So this means it increased there's 5,000 last year, so there's 5,000 more this year, plus 20%. So this is okay to increase over 100%, but it's not okay to decrease over 100%. Hope that makes sense. And then we're going to do one last question. The final question here has to do with percentages once again. Pretty easy way to do percents. It says a high school football stadium has a seating capacity of 4,500 people. Plans have been made to increase the seating 25%. So we're going to take 100% from last year, 100% of the seats, and we're going to increase it 25 more percent. So what's 100% from last year plus 25% more for the next year? That'd be 125%. So here we go, doing over 100% again. Once the new seating is added, what will be the stadium's total capacity? Okay, I just paused the video after that short interruption. Anyway, it says, so if this is what last year was, 100% of that, we're going to do 25% more. Now, there's a couple different ways to do this, but I think the easiest way is to add the two together, makes 125%. So now we have to take 4,500 and increase it 125%. So we're going to move the decimal point, which is right here, back twice, 1, 2. So that changes it into a decimal. So this is like adding tax on. Tax, you know, is 7%. A lot of times you guys would multiply by 1.07. In this case, we're increasing 25%, so 1.25. So we're going to take 4,500 times 1.25. So grab your calculator and multiply that. When I punch it out, I get 5,625. So that's the new capacity, increasing it 25%. I think that's the easiest way to do it, so hopefully this made sense, and you guys all do well on your Iowa assessments. Let's show all the other schools why we're the best school in the city.